Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be discussing literally everything about surface area and volume that you have to know in order to be successful on the Armed Services Vocational Aptitude Battery, that is the ASVAB, as well as the pre-screening Internet-delivered computer adaptive test, that is the PiCAT. More specifically, I'm going to break this video down into three parts. In the first part of this video, I'm quickly going to review the formulas that you have to learn and memorize. As a reminder, you're not permitted to use a calculator or a reference sheet on the actual ASVAB, so you do have to learn and memorize these formulas at some point. Once I do that, I'm going to work out two very easy practice problems to show you the ins and outs of finding volume and surface area of cubes and rectangular solids. And then finally, I'm going to work on 7 challenging word problems that should closely mirror what you should expect to encounter on the ASVAB and PiCAT. So with all that being said, let's go ahead and get started with today's video. So to start, as I just mentioned, we're going to quickly review the formulas that you have to know for volume and surface area. As a matter of fact, I'd like you to actually pause this video and attempt to write the formula to find the volume of a cube, a rectangular solid, a cylinder, a sphere, a rectangular pyramid, and a cone. And let me just say this, if you can't do that now from memory, how are you going to do that on test day? And before you do that though, I also want to give you a little piece of information that's going to make this very easy. To find the volume of a three-dimensional figure, you find the area of its base, and then you multiply it by its height. Again, to find volume, you find the area of the base of the figure, and then you multiply by height. Using that little piece of information, you should almost be able to write the formula for volume for each of these. So go ahead and attempt to do that now. All right, so let's get started by writing the formula to find the volume of a cube. And as I mentioned, volume is nothing more than finding the area of the base and multiplying by height. As far as cubes go, you should know that they have square bases. In addition, you should know that all the sides in a cube are equal. So if this side's A, that means this side's A, and that means this side's A. So how do you find the area of a square? It's S times S, but in this case, we know our side lengths are A, so the area of our square base is A times A. And what is the height of this cube? We can see it's right here. It's A. In short, to find the volume of a cube, it's A times A times A, which is the same thing as A to the third. All right, so let's talk about rectangular solids now. Specifically, let's write the formula to find the volume of a rectangular solid. Again, you want to think about volume like this. Find the area of the base, multiply by height. Well, how do you find the area of the base of a rectangular solid? You should see that the base of a rectangular solid is in the shape of a rectangle. To find the area of a rectangle, it's length times width, and then we're just going to multiply by height. Let's move on to cylinders now. How are we going to find the volume of a cylinder? Well, think about volume like this. Find the area of the base of the figure and then multiply by height. Well, we can see the base of a cylinder is a circle. How do you find the area of a circle? That's pi r squared. So we found the area of the circle. Now we're just going to multiply by the height of the figure. All right, so that's cylinders. What about the volume of spheres? Let me say this about spheres. This is just one that you have to memorize. There's no easy way to think about this one, and it's 4/3 pi r cubed. Just commit that one to memory. There's no easy way to think about it. All right. Now let's talk about rectangular pyramids and cones at the same time, because these are very similar. When you're dealing with anything that's in the shape of a pyramid or a cone, you're always going to put a 1/3 in your formula. And now that we've done that, let's talk about pyramids. What shape is the base of our pyramid? It's a rectangle, but that said, we called our sides A and B. How do you find the area of a rectangle? It's length times width, or in this case, it's going to be A times B, and then we just multiply by height to get the volume. Same thing applies here with cones. What shape is the base of our cone? It's a circle. How do you find the area of a circle? That's pi r squared. And again, we're finding volume, so it's going to be times height. And that's all there is to finding these formulas for volume. It's very easy. Find the area of the base, multiply by height. And that works for cubes, rectangular solids, cylinders, rectangular pyramids, and cones. All right, so now that we've discussed volume, let's talk about surface area. And I'll start by saying this. If I were taking this test, I would not learn all these formulas for surface area. The only two I'd really want to remember is how to find the surface area of a cube and the surface area of a rectangular solid. That is to say, I wouldn't worry about finding the surface area of a cylinder, and I absolutely wouldn't worry about finding the surface area of a sphere. So there's only two additional formulas that we have to be mindful of. Notably, to find the surface area of a cube, it's going to be 6a squared. And what surface area means is this. It means you have to find the area of each of the faces of a cube and add them together. And I'm actually going to show you exactly how we derive this formula in this first example. Apart from that, you also want to know the formula to find the surface area of a rectangular solid. And as you can see, it's 2 length times width plus 2 width times height plus 2 height times length. And when I get to this practice problem over here, I'm going to show you why that's the case. So in short, that's all the formulas you need to learn and memorize. And as you saw, volume is very easy to remember. Surface area, however, can be a little bit more tricky. So now that we've reviewed those formulas, let's go ahead and take a look at two easy practice problems. And as I work out these easy practice problems, I'm going to emphasize some things that are going to help you better understand how to find the surface area of cubes and rectangular solids. All right, so as you can see, number one says, find the surface area and volume of a cube with sides that are 6 inches. Well, as far as finding volume goes, that's pretty easy. The volume of a cube is given by the formula volume equals a to the third. And we know a refers to the length of one of the sides of a cube. According to the problem, a is going to be 6. So this becomes 6 to the third. 6 to the third is the same thing as 6 times 6 times 6. And let's go ahead and work this out. 6 times 6 you should know is 36. So that leaves us with 36 times 6, which I'm going to work off to the side here so as not to make any mistakes. We have 36 times 6. 6 times 6 is 36. Drop down a 6, carry a 3. 6 times 3 is 18, 19, 20, 21. So the volume of this cube is 216, and that's going to be inches cubed. One thing I want to mention is this. Surface area is always going to be squared, whereas volume's always going to be cubed. And as you can see, the volume of this cube is 216 inches cubed. All right, so that's volume. Now let's talk about finding surface area. All right, so finding the surface area of a cube is pretty simple. We just use this formula, 6a squared. All right, so let me stress this. If you just memorize this formula to find the surface area of a cube, chances are you're not going to be able to answer more difficult problems, including some of the more difficult problems that we're going to get to in just a minute. You have to really understand surface area of cubes and rectangles to be successful on the ASVAB. So in light of that, I want to take a few minutes to give you the logic and reasoning behind the surface area of a cube being 6a squared. And first, let me just remind you, surface area means you find the area of each face of a figure and you add them together. So let's think about a cube here. Here's what a cube looks like. what does a cube look like when you unfold it? Well, it looks like this. You have all faces that are identical squares. So you can think of this as the base. This is the left. This is the right. This is the back. This is the front. And this is the top. All these squares are identical. So if I know the area of one of these squares, I know the area of all these squares, and at the same time, I can simply add those together to find surface area. Well, we should also know that uh, all the side lengths in cubes are equivalent. So if this side's A, this side's also A, and how am I going to find the area of this square right here? I'm going to do A times A, which is A squared. If all these squares are identical, that means all their areas are identical. So if this area is A squared, this one's A squared, this one's A squared, this one's A squared, this one's A squared, and this one's A squared. How many faces does a cube have? It has 1, 2, 3, 4, 5, 6 faces. So as you can see, the formula to find surface area of a cube is the area of one of the faces of the cube times 6 to count for all the faces of a cube. All right, so with that in mind, let's get back to our formula here. We know A is 6, so this becomes 6 times 6 squared. 6 squared is 36, so this is 6 times 36. And we work that out right here. We know this is going to be 216, and that's going to be inches squared. All right, so as it happens, sometimes the volume and surface area of cubes are identical. That's not always the case, but sometimes that does in fact happen. All right, so that is that one. Let's go ahead and move on to number 2 here. It says find the surface area and volume of a rectangular prism that has a length of 4 centimeters, a width of 9 centimeters, and a height of 2 centimeters. So I think volume's much easier to figure out. It's always length times width times height for rectangular prisms. And we know what those values are. According to the problem, our length is 4, our width is 9, and our height is 2. So let's plug those in accordingly. This becomes 4 times 9 times 2. 4 times 9 is going to be 36. So this becomes 36 times 2. If you can't do that in your head, you can always work it off to the side. 36 times 2. 6 times 2 is going to be 12. Carry a 1. 3 times 2 is 6 plus 1 is 7. So the volume of our rectangular prism here is 72 centimeters, and it's going to be cubed. All right, so let's find the surface area of this rectangular prism now. And again, that formula is 2 length times width plus 2, and my pen's starting to act up here, 2 width times height plus 2, and this is going to be length times height. All right, so I want to say this again. Unless you really understand how to find surface area, you're going to struggle with word problems that are somewhat challenging. So in light of that, I want to take a few minutes and explain the logic behind how they came up with this formula. And to do that, I'm actually, if I can get my pen in the right spot here, I'm actually going to take a rectangular prism and unfold it so we can take a look at all of its faces. So this right here is the base of a prism. This side right here is going to be the front face of a prism. This will be the back face of a prism. This will be the left side of a prism. This will be the right side of a prism. And this would be the top of a rectangular prism. And if you were to fold this all together, these two sides would stand up, this front and this back would stand up, and this top would fold over and connect. And let me say this. I'm going to use a highlighter for this. This side is the same as this side. That is to say their areas are the same. this back and this front are the same, so they have the same areas. And let's go ahead and use one more color. And this base of our rectangular prism and this top of our rectangular prism are identical, so they're going to have the same areas as well. And with that in mind, let's go ahead and put some labels on this figure. Should be pretty obvious that this is a length right here. Okay, this is going to be a width, and this right here is a height. So how do I find the area of our rectangular base? Well, the area of a rectangle is length times width. And if I know the area of our base here, then I also know the area of the top of this rectangular prism as well. As a matter of fact, that's where we get this part of the formula right here. This part of the formula is the area of both the base and the top of a rectangular prism. All right, so let's go ahead and move on and keep with that logic here. Well, if this is a length, that means this is a length right here. And how do we find the area of a rectangle? It's length times width, but in this case, we have a length and a height. So the area of this back here is going to be length times height. And again, if we know that the area of this back face is length times height, that means the area of this front face is going to be length times height. And if we go back to our formula here, we can see that that is right here. The 2 indicates that we have 2 faces that have areas of length times height. All right, let's go ahead and go back a step here. Now, we know this is a width, but what is this? When we fold this up, this is going to be a height. So the area of this face is h times w. If this area is h times w, that means this area is h times w. And where's that in our formula? That is right here. I wrote hw. You can write it hw or wh. And there's a 2 in front of that because there's this face and this face. All right. So again, surface area means that you find the area of each of the faces in a figure, and in a rectangular prism, we have a top and a bottom that are identical. We have a front and a back that are identical, and we have a left side and a right side that are also identical. All right, so with that in mind, now let's just go ahead and plug these values into this formula to find the surface area of this rectangular prism. We have 2. What is our length? That's 4. What is our width? That's 9 plus 2. What is our width? That's 9. What is our height? That's 2 plus 2. What is our length? That's 4. What is our height? That's 2. So let's go ahead and keep working this out. 4 times 9, as we should know by now, is 36. So this is 2 times 36. 9 times 2 is going to be 18. So this is 2 times 18. And then this is 2. 4 times 2 is 8. Let's go ahead and work this out accordingly now. We have 2 times 36. I'm going to work that off to the side, even though we should know what that is already. We have 36 times 2. 6 times 2, of course, is 12. Carry a 1. 3 times 2 is 6 plus 1 is 7. So this is 72. Let's work out 2 times 18 now. That's 18 times 2. 8 times 2 is going to be 16. Carry a 1. 2 times 1 is 2 plus 1 is 3. So this is plus 36. And you should know that 8 times 2 is 16. Let's go ahead and add these together now. We have 72, 36, and 16. 6 plus 6 is 12. 13, 14, so this is 4, carry a 1. 7 plus 3 is 10, 11, 12. So the surface area of this rectangular prism is 124 centimeters squared. Again, surface area is always going to be squared, whereas volume's always going to be cubed. All right, so now that we've looked at those two examples and I emphasized what surface area was, let's go ahead and work on some practice questions now that should be a little bit more difficult. This first one says a rectangular prism has a length of 10 centimeters and a width of 5 centimeters. If the volume of the prism is 250 centimeters cubed, find the height. So of course, you have to know that to find the volume of a rectangular prism, it's length times width times height. And according to this problem, our rectangular prism has a length of 10, a width of 5, and an unknown height. So we don't know what its height is. In addition, we were told that its volume is 250 centimeters cubed. So let's plug those values in accordingly. Again, we were told that its volume is 250. So in place of V here, I'm going to put 250. We know it has a length of 10, so this is 10, a width of 5, and an unknown height. So we'll just leave that as H. And clearly, by solving this equation for H, we'll be able to answer this question. So let's go ahead and do that. 10 times 5 is going to be 50, so this is 50H equals 250. To get H by itself, we'll divide both sides by 50 now. This crosses out here, leaving you with H on this side. And this math is actually incredibly easy to do. You can cross out these corresponding zeros. What is 25 divided by 5? That's 5. So the height of our rectangular prism has to be 5 centimeters. All right, so that is that one. All right, so number 2 says at Jacksonville's airport, a fueling truck can fill a gas tank at the rate of 250 cubic inches per minute. If a rectangular gas tank is 20 inches long, 15 inches wide, and 10 inches tall, how long will it take the fueling truck to fill this tank? All right, so we're going to be finding the volume of our rectangular gas tank. And since it's a rectangular gas tank, we know it's going to be a rectangular prism. The volume of a rectangular prism is length times width times height. And thankfully enough, we were given all those things in this problem. We know our rectangular gas tank has a length of 20 inches, so L is 20, a width of 15, so W is 15, and a height of 10. So let's go ahead and plug those values in. This becomes 20 times 15 times 10. And you could do this one mentally if you wanted to. You could say 20 times 10 is 200, so that leaves us with 200 times 15. And at this point, I might work this off to the side to be 200 times 15. 0 times 5 is 0. 0 times 5 is 0. 5 times 2 is 10. Before you start multiplication with that 1, you want to bring in a 0 placeholder. 1 times 0 is 0. 1 times 0 is 0. 2 times 1 is 2. So right here we have 1,000 plus 2,000, which is 3,000. All right, so the volume of our rectangular gas tank is 3,000 cubic inches. Now let's go back to the other part of this problem where it says the fueling truck can fill a gas tank at a rate of 250 cubic inches per minute. So to figure out how long it's going to take this truck to fill up our tank, we're going to take the volume of our tank, which is 3,000, and we're going to divide that by how much volume of gas this fueling truck puts into the tank per minute, which is going to be 250. All right. So let's cross out these corresponding zeros to make this math a little bit easier. And you should be able to do this mentally, but if you couldn't, you could always read this as 300 divided by 25. And when you do long division, you start by asking yourself this: how many times does 25 go into 3? Doesn't. How many times does 25 go into 30 without going over? Well, that's going to be 1 time. 25 times 1 is 25. 30 minus 25 is going to be 5. Drop down this 0. Now the question is, how many times does 25 go into 50 without going over? That's going to be 2 times. Given that 2 times 25 is 50. 50 minus 50 is 0. So 300 divided by 25 is 12. In other words, it takes 12 minutes for this fueling truck to fill up our rectangular gas tank. So that is that one. All right, so number 3 says Tim has a rectangular prism with a length of 10 centimeters, a width of 2 centimeters, and an unknown height. He needs to build another rectangular prism with a length of 5 centimeters and the same height as the original prism. The volume of the two prisms will be the same. Find the width in centimeters of the new prism. All right, so there's quite a bit going on in this problem, and let's take it step by step. First of all, let's talk about finding the volume of this first prism. So I'm going to call that volume of prism 1. Well, we know how to find the volume of rectangular prisms. That's length times width times height. And let's see what was given according to this problem. Has a rectangular prism with a length of 10, so we know L is 10, and a width of 2, so W is 2. Height is unknown according to the problem. So let's plug those values in. We have a length of 10, so this is 10. A width of 2, so that's 2. And the height is unknown, so we'll leave that as H. 10 times 2 is going to be 20, so this is 20H. The volume of our first prism is 20H. All right, and that's all we could get from that. And let's go ahead and take a look at the second part of this problem. He wants to build another rectangular prism. So we're going to be finding the volume of a second rectangular prism, which I'm going to call V2. And we know how to find the volume of rectangular prisms. It's length times width times height. With a length of 5, so L is 5, and the same height as the original prism. The volume of the two prisms will be the same. So let's try to express that mathematically. The volume of this first prism has to equal the volume of this second prism. Find the width in centimeters of the new prism. All right, so let's go ahead and fill this in. We know that the length of our new prism is 5. We're trying to figure out what its width is, and we're told that its height is the same as this height, so we're going to have to leave that as H for the time being. That said, we know the volumes of these two prisms are the same. So the volume of prism 1 was 20H. That means the volume of prism 2 is also going to be 20H. So in place of V2 here, I can go ahead and plug in 20H. So this becomes 20H equals 5 times width times height. And it should be pretty clear now that we're going to be solving for W. And if we divide both sides by 5H, let's see what happens. Well, this H crosses out here, and these 5's cross out here, leaving you with W on this side. These H's cross out here, and 20 divided by 5 is 4. So the width of the second rectangular prism is going to be 4 centimeters. All right, so that is that one. Pretty challenging, but that said, if you understand how to find the volume of a rectangular prism, and you follow the instructions in the word problem, it's not that difficult at the end of the day. All right, so number 4 says you are asked to paint the ceiling and walls of a room. The room is 10 feet wide, 15 feet long, and 10 feet high. Calculate the surface area so that you can determine the gallons of paint needed. If a gallon of paint covers 175 square feet, how many gallons do you need to paint the room? All right, so clearly we're going to be finding surface area of this room. So to find the surface area of a rectangular prism, you may recall that surface area equals 2 length times width plus 2 width times height plus 2 height times length. And again, each of these is the area of the 6 faces of our rectangular prism. Now, let me go ahead and take a rectangular prism and unfold it for you because we're going to have to pay close attention to the wording of this problem to get it correctly. So here is our floor of our rectangular prism. That means that this is the back wall. This is our front wall. This is our side wall. This is our side wall. And this is our ceiling. All right. So remember, we're painting this wall, this wall, this wall, this wall, and our ceiling. We are not painting this floor. So we're going to have to modify this surface area formula to exclude the area of this floor. And what is the area of this floor? Well, we have a width here and a length here. So the area of this floor is length times width. So here's the modification we're going to make. This is going to become surface area. Again, we're excluding the floor, which is one of these lengths times widths. This ceiling is also length times width, so we need one of those. So this is going to become length times width plus 2 width times height plus 2 height times length. All right, so that's why I unfolded that rectangular prism. So you can see that we have to exclude the floor, which we are not painting, which means we have to remove this 2 here and just leave it as length times width. All right, so with that done, let's go ahead and plug in values accordingly. We know what they all are. W is 10, L is 15, and H is 10. So W is 15, so this becomes 15 times width is 10 plus 2. Width is 10, height is 10 plus 2. Height is 10, and length is 15. All right, let's go ahead and work this out. This should actually be pretty easy to do mentally. 10 times 15 is going to be 150. This is going to become 2 times 10 times 10 is 100. And 10 times 15 is going to be 150. So this is 2 times 150. Let's go ahead and keep working this out. This is 150 plus 2 times 100 is going to be 200 plus 2 times 150 is going to be 300. 150 plus 150 is 300. Let's keep working this out. This is 200 plus 300, which is 500. So this is 500 plus 150. So this is going to be 500 plus 150, which is 650. All right, so the total surface area that we're going to be painting is 650 square feet. All right, so we know that we're painting 650 square feet of wall and ceiling space. So this is going to be 650, and we're going to divide that by how many square feet each gallon of paint covers. According to the problem, each gallon of paint covers 175 square feet. So by doing 650 divided by 175, we'll know how many gallons of paint we need. And we could read this as long division like this. 650 divided by 175. And we start by asking ourselves, how many times does 175 go into 6? It doesn't. How many times does 175 go into 65? It doesn't. How many times does 175 go into 650 without going over? Well, it's going to either be 3 or 4 times. So I'm going to say it's 3, but I'm also going to work out 175 times 3 and 175 times 4, just to confirm that. 5 times 3, of course, is 15, so drop down a 5, carry a 1. 7 times 3 is 21, plus 2 is 22. Drop down a 2, carry a 2. 3 times 1 is 3, plus 2 is 5. So 3 gallons of paint covers 525 square feet. What about 4? Uh, 5 times 4 is 20, so bring down a 0, carry a 2. 7 times 4 is 28, 29, 30. Bring down a 0, carry a 3. Uh, 4 times 1 is 4, plus 3 is 7. So 4 gallons of paint covers 700 square feet of area. So clearly, if I were to do this long division here, this would be 3.7 something and so on and so forth. But it should be pretty obvious that if you get 3 gallons of paint, you're only going to be able to cover 525 square feet, which is not enough to cover our 650 square feet. So that means you're going to have to buy 4 gallons of paint, which will cover 700 square feet, and that's going to be enough to cover our 600 square feet for our walls and our ceiling. So the answer to this one is 4 gallons. All right, so number 5 says, at Home Depot, you bought 2 boxes. The first box has a square base. Each side of its base measures 10 units, and it is 4 units high. The second box is rectangular, and it has twice the volume of the square box. If the height of the second box is 5 units and its width is 10 units, what is the length of the second box? All right, so I know we're talking about boxes, and when people hear the word box, they automatically think of cubes. But in this case, we're actually working with 2 rectangular prisms. And more specifically, we're working with the volume of 2 rectangular prisms. So the volume of one of our rectangular prisms is going to be length times width times height. And the volume of our other rectangular prism is going to be length times width times height. And let's see what information we're given about these rectangular prisms. This first rectangular prism, which is over here, this is the volume of the first box, has a square base. Each side of its base measures 10 units. So the length and the width of the base of this box is going to be 10. So length and width is 10, and it is 4 units high. So H is 4. Let's go ahead and plug that in accordingly. This becomes 10 times 10 times 4. 10 times 10 is 100. 100 times 4 is 400. So the volume of this first box is 400, and it just says units. So this is units cubed. All right, so we found the volume of our first box. It has twice the volume of our second box is rectangular, and it has twice the volume of the square box. So volume 2 is going to be twice the volume of the first box. All right. Well, we can actually figure that out. What is the volume of the first box? It's right here. It's 400. So this becomes 2 times 400. 2 times 400 is 800. So the volume of our second box is going to be 800. It has a height. If the height of the second box is 5 units, so H is 5, and its width is 10 units, so W is 10. What is its length? So that's unknown. So let's go ahead and plug these things in. We know the volume of our rectangular box is going to be 800. We know its length is what we're trying to figure out. Its width is 10, and its height is 5. So clearly, we're going to be solving for L in this case, and that's actually pretty easy to do. This becomes 10 times 5, which is 50. So this is 50L equals 800. Let's divide both sides by 50 to get L by itself. This crosses out here, leaving you with just L. We can cross out these corresponding zeros, and now we're left with 80 divided by 5, which I know many of you can do in your head, but let's go ahead and work it out. 5 goes into 8 one time. 5 times 1 is 5. 8 minus 5 is 3. Drop down this 0. 5 times 6 is 30. 30 minus 30 is 0. So the length of this rectangular box is 16. And of course, that's 16 units. since we weren't given a unit of measurement. So the answer to this one is 16. All right, so number 6 says a cylinder has a volume of 502.4 centimeters cubed and a radius of 4 centimeters. What is the height of the cylinder? Use 3.14 in place of pi. All right, so we are working with a cylinder here. So if it's helpful and you can't visualize what we're doing, you can quickly make a sketch of a cylinder here. Let me draw that line a little bit better for you. More specifically, we're finding the volume of a cylinder. And you should recall my definition of volume. Volume is the area of the base times the height of the figure. Well, a cylinder has a base that's in the shape of a circle. So the area of a circle is pi r squared. And of course, I just said you multiply the area of the base times the height. So that's the formula to find the volume of a cylinder. We can label the rest of this if we want, but it's not really necessary. We know this cylinder has a radius of 4 and a height that is unknown. So we'll leave that as h. So let's get back to the problem now that we've derived our formula just by looking at our figure. We know this cylinder has a volume of 502.4. So our V is 502.4. Our radius, or R, is 4. And we don't know what its height is. So we're ultimately going to be solving for H. So let's start plugging those things in. We're told our volume is 502.4. So in place of V, we'll go ahead and put 502.4. We were told to let pi be 3.14. So this is going to become 3.14. Our radius is right here. It's 4. So this is 4 squared. And our height's unknown. So we'll leave that as h. Let's keep working this out. This is 502.4. 4 squared is 16, so this becomes 16 times 3.14 times h. And I'm going to work this out off to the side so as not to make any mistakes there. We have 16 times 3.14. Well, as you can see, we're multiplying a whole number, notably 16, by a decimal, notably 3.14. So what you want to do is take your decimal and shift it 2 times to the right. Rewrite this as 314 times 16, albeit with no decimals. And once we do this, we're going to take the 2 decimals that we shifted to the right here, and we'll shift them to the left in our answer. So let's work this out. 6 times 4 is 24, so drop down a 4, carry a 2. 6 times 1 is 6, plus 2 is 8. 6 times 3 is 18. Before we start multiplication with this 1, we have to bring in a 0 placeholder. 1 times 4 is 4. 1 times 1 is 1. 1 times 3 is 3. Let's add these together now. 4 plus 0 is 4. 8 plus 4 is 8, 9, 10, 11, 12. So bring down a 2, carry a 1. 8 plus 1 is 9, plus 1 is 10, so bring down a 0, carry a 1. 3 plus 2 is 5. Bring our 2 decimals back into the left. 1, 2. So this becomes 50.24h equals 5. My pen will let me write it. 502.4. And now we're just going to divide both sides by 50.24. Get h by itself. This crosses out here, leaving you with h on this side. And now we got to work this out. And this one should be pretty easy to do. 502.4 divided by 50.24. Well, you should know that that's going to be 10. So h in this case is 10. All right, so that is that one. I would work this out for you, but you should see 502.4 divided by 50.24 is just 10. If you multiply 50.24 by 10, you'll get 502.4. All right, so the correct answer to this one is C, 10 centimeters. All right, number 7 says for a sphere, the volume is given by volume equals 4/3 pi r cubed, and the surface area is given by area equals 4 pi r squared. If the sphere has a surface area of 256 pi, what is the volume? All right, so we're going to start with surface area, and we know that formula because it was given to us in the problem is 4 pi r squared. What's more, we were told that the surface area, our SA, was 256 pi. All right, so let's go ahead and think about what we're going to have to do to solve this one. We want to know the volume of this sphere. So that's going to be volume equals 4/3 uh, pi r cubed. What are we missing to find the volume of this sphere? Well, we're missing r. We don't know what r is. And that is the only thing that we have to plug in here to find the volume of this sphere. That said, we're going to use this information given about surface area to figure out what r is, and then ultimately we'll be able to find its volume. So again, SA is 256 pi. So in place of SA over here, I'm going to put 256 pi equals 4 pi r squared. All right, so we're going to be solving for r here, which is going to enable us to find the volume of this sphere. So let's go ahead and divide both sides by 4 pi to get r squared by itself. This crosses out here, leaving you with r squared over there. And what happens here? This pi crosses out right here. And now we can do this, 256 divided by 4. We ask ourselves, how many times does 4 go into 2? It doesn't. How many times does 4 go into 25 without going over? It's going to be 6 times. 6 times 4 is 24. 25 minus 24 is 1. Drop down the 6. How many times does 4 go into 16? Well, that's going to be 4 times. 4 times 4 is 16, so there is no remainder. So this becomes 64 equals r squared. Again, we just want r. So we're going to take the square root of both sides to get r by itself. This becomes r equals the square root of 64, which is 8. So r is 8. Now that we know r is 8, we can go ahead and plug it in here and figure out what the volume of this sphere is. So this becomes volume equals 4/3 pi, and then it's going to be 8 cubed. All right, so volume equals 4/3 times pi times 8 cubed. 8 cubed is the same thing as this. It's 8 cubed is 8 times 8 times 8. 8 times 8 is 64. What is 64 times 8? So as not to make a mistake, I'm going to do that off to the side. We have 64 times 8. 4 times 8 is 32, so drop down a 2, carry a 3. 6 times 8 is 48, 49, 50, 51, so this is 512. This becomes 4/3 times pi times 512. So let's go ahead and work on simplifying this. We're going to do this off to the side. We can do 4/3 times 512 off to the side like this. And again, we can regard this like this. 4/3 times 512 over 1. You can write any whole number as a fraction by placing it over 1, which means we're going to do this. We're going to multiply straight across such that this becomes 4 times 512 over 3 times 1. 3 times 1 is just 3, so we can go ahead and work that out very quickly. Let's do 512 times 4 now. 2 times 4 is 8. 4 times 1 is 4. 5 times 4 is 20. So this is 2048 over 3. All right, so this is going to be 2048 over 3 pi. And I'm going to leave it like that. I'm not going to work this out and get you a decimal. And I'm not going to multiply it by 3.14 for pi. So the answer to this one is 2048 over 3 pi. That is the volume of our sphere. All right, so that was it for this video. Honestly, finding surface area and volume can be pretty challenging, as you just saw. And it takes a little bit of practice to fully understand surface area in terms of being able to solve some challenging word problems. As always, I hope you found this video helpful. And as usual, you're more than welcome to leave feedback in the comment section below. If you want to help my channel out, please consider subscribing to it. I'll just say this again. Even I find finding surface area and volume very challenging. So if you struggle with this, just bear in mind that you're probably not alone. And on that note, I'm going to go ahead and cut you loose.